Welcome back to Mr. Hassan's Maths channel. I'm now going to be going through this paper, which is the Cambridge IGCSE February-March 2020 0580 syllabus. This is paper 4, variant 2. Okay, this is the extended syllabus, and I'm going to be going through these questions, and I will be making videos, and I'm not going to make one video of the whole paper. I'm going to make videos which are split up into different parts depending on what topic they are covering, because I like to save my questions according to topic as well as according to paper. So each question will go into two playlists, or each video I make will go into two playlists. One of them will be the playlist for the actual year, this particular session, and the other playlist will be for the topic that the question is from. So what I'm going to do first here is go through question number 1. This is just normally the first question in a paper 4 is something dealing with kind of basic kind of arithmetic, things to do with just basic arithmetic, ratios, percentages. Those type of questions are normally the first question in a paper 4. So that's the same kind of pattern you see here. This is about this guy called Danu, who has a model railway. It's a model railway. He has a train that consists of a locomotive and 4 coaches. The mass of the locomotive is 87 grams, and the mass of each coach is 52 grams. Work out the total mass of the train. Well, basically, you've got the locomotive, which is 87 grams, plus 4 times 52. Simple as that. Okay, so it's 87 plus 4 times 52. So you can just stick that in your calculator. 4 times 52, and that should give us the correct answer, which is 295 grams. Remember, this is a model, that's why it's so light. Okay, now, part 2 says, work out the mass of the locomotive as a percentage of the total mass of the train. So when they say work out the mass of, or work out something as a percentage of something else, okay, work out A as a percentage of B. Okay, what comes after the word of is always the denominator. So work out the mass of the locomotive as a percentage of. So after the phrase as a percentage of, when it says as a percentage of, what's after that, okay, is going to be in the denominator. So the total mass of the train, which we just worked out, is 295. And the mass of the locomotive is going to be the numerator, which is 87. So it's 87 over 295. So you make a fraction from this, and then you turn it into a percentage by multiplying by 100, and your unit will be a percent. So you take this, you multiply by 100, and your answer will be in percent. Okay, so you're changing this into basically what you're doing, you're changing it into a fraction out of 100. That's what you're doing. So you multiply by 100, and that answer will be as a percent. Okay, so that's something that we should understand. So when it says work out the percentage, the mass of the locomotive as a percentage of the total mass, is the mass of the locomotive divided by the mass of the total mass of the train, and turn that into percentage by multiplying by 100, and you have to put percent in your answer. So you're going to have 87 over my last answer, which was 295, multiplied by 100. So you don't write percent here, you just put times 100, but your answer is going to be a percentage. Now that comes out as a decimal as 29.4915. 29.4915%. Now what you do is if it's not otherwise stated, as it is mentioned in the front of the paper, it says here, give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles in degrees, unless a different level of accuracy is specified in the question. So that means if the answer is not exact, you should round to 3SF if it's a percentage. So that's what we have to do here. We round to 3SF, so it's going to give you 29.5%. 29.5%, that is the mass of the locomotive as a percentage of the total mass of the train. Part B says the train is 61 centimeters long and travels a speed of 18 centimeters per second. It takes 4 seconds for the whole of the train to cross a bridge. Calculate the length of the bridge. So this question is kind of to do with speed and time and distance, but I'll just include it with arithmetic because it's a pretty simple question. But this is actually one that is important for us to understand. So the train is 61 centimeters long and travels at a speed of 18 centimeters per second. It takes 4 seconds for the whole of the train to cross a bridge. So we're dealing with distance, we're dealing with the speed, and we're dealing with the time. And we know that speed is equal to distance over time. That's what we know. So we got to calculate a distance. We got to find the distance or the length of the bridge. So distance is equal to speed multiplied by time. All right, so we know that the total distance that the train has traveled when it crosses the bridge is given by 18 centimeters per second times 4. Because what's happening here is you have a train. Let's say this is the length of the train. Let's say this is 61 centimeters. That's the length of the train. It's going to reach a bridge. Okay, it's going to go over a bridge. This is all model. It's not a real bridge. All right. The time it takes for the whole of the train to cross the bridge is not just this distance. Okay, it's this distance plus the distance of the train. So it has to say this has to travel, the front of the train has to travel from here all the way to there, okay, for it to have crossed the whole bridge. So what you need to find is the distance or the length of the bridge plus the length of the train. That is the distance that this train has traveled. Okay, so the distance it's traveled is 61 plus, or you can say x plus 61. That's the distance that the train has traveled, okay, in this 4 seconds. So you can say that the distance is speed times time. We know that the distance is x plus 61, and the speed times the time it takes is 18 times 4. So you have 8x plus 61 equals 18 times 4. That's 40 plus 32. That's 72. So x plus 61 equals 72. Let's just make sure we didn't do anything silly there. 18 times 4 gives us 72. That's right. So x is 72 minus 61, which is 11. So it's 11 centimeters. So the length of the bridge is 11 centimeters. Okay, so we know the distance in terms of how far the train has to travel in terms of the unknown length of the bridge we call x plus the length of the train. And we know the distance in terms of speed times time. And therefore we can find the total distance that this train has traveled. Now it says part C, a new locomotive costs $64. Calculate the cost of the locomotive in rupees when the exchange rate is 1 rupee equals 0.0154 dollars. Give your answer correct to the nearest 10 rupees. So this is a question about exchange rates. Okay, so what I'm going to do is I always like to put the unknown on top. So calculate the cost of the locomotive in rupees. So X rupees, okay, is what $64 is worth. And we know that 1 rupee is worth $0.0154. So you can set up a very nice little cross multiplication here. So you have x equals 64 divided by 0.0154. So we can just take the calculator and put these values in. So you have 64 over 0.0154, and that gives us 4,155.844. So you get 4,155.844, and that's in rupees. Now, if this question did not state otherwise, we would have to round this to 2 decimal places because it is currency, it's money. Okay. Now, what I read out in the earlier part of this question is that non-exact answers should be given to 3 significant figures or 1 decimal place for angles when the angles are in degrees, unless a different level of accuracy is specified in the question. Now, in this question here, if it hadn't specified otherwise, it's currency. Currency is one of the exceptions to those rules. If the answer is not exact, if the answer is not an integer, in fact, it should be given to 2 decimal places. So even if your answer came out, for example, as 8.5, you write your answer as 8.50 for currency, money. Okay? If it comes out as a whole number, you leave it as it is. If it was 8, you leave it as 8. You don't put 0.00 if the answer was an integer. But if it's a non-integer, even if it's one decimal place, you have to add an extra 0 to it. If it's more than that, you round it to 2 decimal places. Okay, that's for currency. But of course, this question is stating otherwise. It says, give your answer correct to the nearest 10 rupees. Because of that statement, of course, now we must round it to the nearest 10 rupees. So we look at the position of the tens, which is this position over here, where this 5 is. What's after is a 5, so it becomes a 6. So you get 4,160 rupees. Okay, you can think of it as 4,155.8 rupees. To the nearest 10 is closer to 4,160 rupees. Okay, so there's the answer for part C of this question. Now we're going to go on to part D. Okay, part D is about percentage, and this is a very important question actually, because this is about reverse percentages, which many students make big mistakes with. All right. Here it says the cost of a railway magazine increases by 12.5% to $2.70. Sorry. Calculate the cost of the magazine before this increase. So we know the price after the increase, but we do not know the price before the increase. All right, and this is where many students make a mistake. A lot of students, they will take 12.5% of this price, 2.70, and they will subtract that value from it. But there's a problem with that, because 12.5% of 2.7 is not the same as 12.5% of what the actual value was before it was increased. So you cannot do this method. You cannot use this method. What you must do is, there's two ways. The way I prefer is to say, let's say we got the price before and the price after like this. We're looking for a cost, so I'm going to put the cost on top. Now I know after the increase it became 2.70. Before the increase, I don't know what it is. So I'll write X. Now the original price is always 100%. The before price is always 100%. That's the original price. Now if this thing has increased, which it has, okay, you add that increase percentage to 100. So 112.5% is what percentage the new price is of the old price. Okay, we need to find what the old price was. So now we can simply cross multiply. X is equal to, I'm going to write this over here because I'm going to show you another method. X is equal to, you're going to have 2.7 times 100 divided by 112.5. Okay, you don't need the percent because they cancel out. And that will give you your answer. So we can just put that in the calculator. We have 2.7 times 100 divided by 112.5. And that gives us 12 over 5, which is 2.4. 2.4. So remember, we write this as 2.40 because it's currency. We write it to 2 decimal places, even if the answer comes out as 1 decimal place. Okay, you add a 0 to it because it's not an integer answer. If the answer came out as $2, we would leave it as 2. But it's 2.4, we write 2.40. Okay, I'm going to show you an alternative method also of answering this question, which basically what you can do is you can say, okay, we know that something has increased by 12.5%. So it's 100% plus 12.5%. If we knew it decreased, we'd do 100% minus 12.5%. And that gives us 112.5%, which as a decimal is 1.125. Divide by 100, write that as a decimal. So we know that the original price, let's call it X, was increased by 12.5%. So now it's 1.125 multiplied by its original value, gave us a new value, which is 2.7. So when you increase something by 12.5%, it's like you're multiplying it by 1.125. You're multiplying by 112.5%, which is over 100. So that means X is equal to 2.7 divided by 1.125, which, if you calculate that, it gives you exactly what we have here, just to confirm it with you. So 2.7 divided by 1.125, and you get the same answer, which is 2.4. So that's an alternative method of answering this same question. Okay, now, part E. It says, Dhanu plays with his model railway from 6:50 to 11:15. That's both like 24-hour clock services in the morning, basically before noon. He then rides his bicycle for 3 hours. Find the ratio of time playing with the model railway to the time riding the bicycle, give your answer in its simplest form. So first of all, let's try to work out the time between these two. Okay, we can work it out in hours, we can work it out in minutes if you want, but there's different ways we can do this. One way of doing this is you can say, all right, let's think about 6:50 to 7 first. 6:50 to 7 o'clock in the morning. Well, we can see that that is 10 minutes. 10 minutes. And then we can say from 7 to 11. Okay, we can see that that's 4 hours. And then we can say from 11 to 11:15. Well, that's 15 minutes. So we got altogether 4 hours and 25 minutes. Okay, 4 hours and 25 minutes. Now 25 minutes is, you can now, what we can do is we can convert this into minutes, or we can convert this all into hours if you want. Now, I'm also going to show you, before I do that, I'm going to show you an alternative way of working out this time. If you want to find the difference between two times, you can set it up like this. You can say 11:15 and 6:50. Now, this is hours and this is minutes. Now, I can't subtract. I want to subtract to find the difference between them. I can't subtract 50 from 15. So I have to borrow 1 hour from here. So this becomes 10 hours. Now 1 hour in minutes is 60. So I have to add 60 to this, 60 minutes. So that's going to give me 75 minutes. Subtract them, that gives me 25. Subtract them, that gives me 4 hours and 25 minutes. Exactly what we found there. So two different ways of finding how much time is between two times. Okay, so that's 4 hours and 25 minutes. So now there's two ways we can deal with this now in terms of ratios. One way is to change everything into minutes. So I know that 4 hours and 25 minutes is 4 times 60 plus 25, which is 240. That's 265 minutes. Okay, and then I can work out the ratio of the time playing with the model railway is 265 to 3 hours, which is 3 times 60. Okay, 3 times 60, so it's 265 to 180, which we can then work out. So 265 over 180, and that gives us 53 over 36. So the ratio is 53 to 36. Alternatively, we could work out everything in terms of hours. So we can say 4 hours and 25 minutes. Okay, that's equal to 4 and 25 over 60. So let's work out what that is. So you have 25 divided by 60. That's a quarter of an hour. No, it's not a quarter of an hour. That's 50 minutes. 5 over 12. Okay, so we can say that's 4 and 5/12. 4 and 5/12. I think this is going to be more complicated. Okay, because you're going to have 5/12 is something which is 25 over 60. It doesn't give you a number it gives you a fraction which is recurring. So it's going to be more complicated, but it's still possible. You should say 4 and 5/12. If you write that as an improper fraction, okay, 4 and 5/12. 5/12. Okay, oops. That gives you 53 over 12. So you could do it this way. You could say that's 53 over 12, and the ratio is to 3. So you multiplied both sides by 12, and you end up with 53 to 36. Same answer. Okay, you could do it that way if you want. In hours, I think doing it in minutes is easier, but this is the answer in the end. 53 to 36 is the ratio of the time playing with the model railway to the time riding the bicycle, and the answer in the simplest form. That doesn't simplify any further than that. And then part F. Again, another question, this time about percentages, and this is about exponential increase. It says the value of Dhanu's model railway is $550. This value increases exponentially at a rate of R% per year. At the end of 5 years, the value will be $736. Calculate the value of R. So there's two ways to do this question again. One way is to do it using the understanding that this is an exponential increase. So we can say that the value that it was, which is 550, was multiplied by a multiplying factor, which we don't know. I'm going to call it X. And in the end, we'll find out what R is. X for a number of years, which was 5 years. And that gave us the new value, which is $736. So we can say that multiplying factor to the power 5 is 736 over 550. So X is going to be the fifth root of that. Okay, now that multiplying factor is basically made up of 100% plus R%. Okay, that's what this is made up of. So 100% plus R% is equal to this. Okay, is equal to this, which is the fifth root of 736 over 55. Okay, that's what this multiplying factor is made up of. And 100% is basically 1. Okay, and this is like R over 100 equals the fifth root of 736 over 55. So you can say that R over 100, I've run out of space here, I'll just write down here, is equal to the fifth root of 736 over 550. The 0 disappeared there for some reason, be careful of that, minus 1. So the answer is going to be R equals 100 times the fifth root of 736 over 550 minus 1. The minus 1 is not inside the square root sign. Okay, and that will give us our answer. So let me just put that in my calculator and make sure that you do it properly. It's very easy to make a mistake here when you're using your calculator. So you've got the fifth root of. Now the fifth root, you're going to use this button over here. So you press shift and this button, and you can choose what root to use there. And then inside here, I need a fraction, 736 over 550. Don't forget the 0 there. Then you have to come out of the square root sign and put minus 1. That 1 is not part of the square root, the fifth root sign, sorry. Then close the bracket, and that should give you your answer, which is 5.999. So R equals 5.999. Okay, which is going to be 6.0023 SF, because it's not an exact answer. So, of course, if you stop there, that's going to change to a 10. Of course, it's going to be 0. That carried 1 over. That's going to change to a 10. Carry 1 over, you get 6.00. That's one way of doing it. The other way of doing it is to memorize the formula that, the new value is equal to the principal value, the original amount, times 1 plus R over 100. That's for compound percentages and to the power of n, sorry. Compound percentages and exponential increase, when something increases by a certain amount every year, like this particular case. So the new value is 736. That's equal to the original value, which is 550, times 1 plus R, which we have to find, over 100 to the power of 5. Okay, so we'll see that we'll end up getting exactly the same equation when we rearrange this, because you end up with 736 over 500 equals 1 plus R over 100 to the power of 5. So you have the fifth root of 736 over 550. See, my numbers keep changing here. Be very careful of that. Not making silly mistakes like that. 736 over 550. Okay. Equals 1 plus R over 100. And the rest is exactly the same here, as you can see. So we can subtract 1 from this. So we have the fifth root of 736 over 550 minus 1 equals R over 100. So therefore you can say R is equal to 100 times the fifth root of 736 over 550 minus 1. So all of this under the fifth root minus 1 outside the root. It's exactly the same stage we got to there. They're exactly the same thing. And so the answer is going to be the same. So this one way is by memorizing the formula. The other way is by thinking about the multiplying factor and then realizing that the multiplying factor is equal to 100% plus the rate the rate that was increasing by. Okay, so that's what the multiplying factor is. Or you can do it this way, directly using the equation, okay, for compound percentages or for exponential increase. If it was a decrease, you just put a minus here and a minus here if it was a decrease. Okay, if it was a decrease. All right, so there's the answer to part F, and that concludes this question number 1 from this paper, which is the February-March 2020, paper 4, variant 2. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from the topic of basic arithmetic. I guess I'll add this to also percentages and also to ratios as well you'll find in the playlists that will appear in these areas. And you can also subscribe to my channel by clicking the link in the middle. Don't forget to look at the descriptions and the under the video to see other material that you might be interested in, A-level AS material as well. Thank you for watching and see you soon.